All right, let's talk about something we all use every single day, but maybe don't think about. You know how one single server can run a website, a database, and a streaming service all at the same time? Well, today, we're going to pull back the curtain on the amazing tech that makes it all happen. We're talking about the hypervisor, the real engine behind the cloud. So, it really all boils down to this one big question. How in the world can a single physical hunk of metal, a computer, act like it's hundreds of different machines all at once? I mean, think about it. One box is running your favorite website, another part of it is handling an email server, and it's also streaming a video, all at the same time, like they're totally separate. How is that possible? Well, the answer is hidden away inside places that look like this, these massive, sprawling data centers. These are basically the hearts of the internet. And inside these buildings, there's one rule that trumps everything else: efficiency. Every single piece of hardware, every server has to be working as hard as it possibly can, 24/7. And that brings us right to the core problem that engineers were wrestling with for years. How do you squeeze every last drop of performance out of a single powerful machine? Okay, picture this. You've got a supercharged 8-cylinder engine, but you're only letting it run on one cylinder. It's kind of what was happening in data centers. Servers were getting more and more powerful, but they were basically stuck in first gear. You had all this incredible computing power just sitting there doing nothing. A huge waste of potential, right? So how did they fix this? What was the breakthrough? Well, the answer was a truly revolutionary idea called virtualization. So what is virtualization? At its heart, it's all about separation. It's this clever technique for, separating a software service, like an operating system, from the actual physical hardware that's delivering it. You're basically creating a virtual, software-based version of a computer that acts and feels just like the real thing. And let me tell you, this idea absolutely changed everything. All of a sudden, you could run multiple, completely different operating systems, like, say, a Linux server and a Windows server, on the exact same physical machine. This just massively cranked up how much you could use your hardware. It gave data centers this incredible new flexibility and efficiency they'd never had before. Okay, this all sounds pretty amazing, almost like a magic trick. But what's the actual piece of software that performs this trick? What's the secret ingredient that makes it all possible? Well, say hello to the hypervisor. You can think of it like a traffic cop for all the server's resources. It's this super thin layer of software that sits right on top of the bare metal, the physical hardware itself. And its entire job is to create and manage all these different virtual machines, making sure they all get what they need and play nicely together. Now, you should know not all hypervisors are built the same way. There are really two main design philosophies. You've got the monolithic approach, which basically packs everything, including all the device drivers, into one big package. It can be super efficient, but if one little thing goes wrong, a single bug can crash the whole system. Then you've got the microkernel approach. This one keeps the core hypervisor really small and lean, and it moves all that other stuff, like the drivers, into separate modules. This is a huge win for security and stability, because a problem in one part won't bring the whole server down. And that lean, super efficient microkernel design, that's exactly what we're going to look at right now. So let's do a deep dive into one of the most important and influential hypervisors ever created, Xen. Okay, so this diagram right here is going to be our roadmap. I know, it might look a little complicated at first glance, but it's a brilliant picture of how the Xen hypervisor organizes a whole computer system. We're going to break it down layer by layer, starting right at the bottom. So right at the very bottom, we've got the foundation, the physical hardware itself. This is the stuff you can actually touch, the real-world CPU, the memory sticks, the storage drives, all of it. Sitting right on top of that hardware is the Xen hypervisor. And notice how thin that layer is? That's the microkernel idea in action. It only handles the most critical, most essential tasks, like scheduling the CPU and managing memory. And because it's so small, it's incredibly fast and super secure. And then, living on top of the hypervisor, we have the guests. Now, in the world of Xen, each virtual machine with its own operating system is called a domain. So here you can see a bunch of different guest domains. Maybe one is Linux, another is Windows, and they're all running happily in their own little isolated sandboxes. But hang on a second. If you look closely at that diagram again, you'll notice that one of those domains looks a little different. It's called Domain 0. And this, my friends, is the absolute secret sauce of the whole Xen architecture.
So domain zero is the real key to how Zine works. It's not just another guest. It's a special, privileged virtual machine that gets to load up first when the server boots. And because it's privileged, it has direct access to the physical hardware. It's the one that manages all the device drivers, it allocates resources like memory and network access to all the other guest domains. To put it simply, it's the brains of the whole operation. It's the master controller.
Okay, so we've gone pretty deep into the nuts and bolts here. Let's pull the camera back a bit and talk about why this elegant design has been so unbelievably important.
Look, this isn't just some clever idea from a computer science textbook. This hypervisor technology, which was really pioneered by systems like Zine, is the fundamental building block of the entire modern cloud. I mean, every single time you spin up a virtual server on Amazon Web Services or Google Cloud or Microsoft Azure, you are using a hypervisor. It is literally the engine that makes the whole cloud go. And this really brings us full circle back to that core idea we started with. There's a great quote from our source material that just says it all perfectly. It says that virtualization is a technique for separating a service from the underlying physical delivery of that service. I mean, that's it right there. It unlocked the true potential of computer hardware by creating this incredibly powerful separation between the service, what we want the computer to do, and the physical machine that's actually doing the work. So, we've seen how separating software from hardware completely revolutionized computing and built the world we live in today. It makes you wonder, right? What's the next great separation? Are we going to see a separation of data from applications? Or maybe, with things like quantum computing, we'll see a separation of computation itself from the classical laws of physics. Whatever it is, you can bet the next giant leap is just around the corner.